Good morning, all of you. So, in today's class, we will learn apparent shift of an object due to refraction. Apparent shift of an object due to refraction. Apparent shift of an object due to refraction. So, let me draw first diagram, then you will understand what is this actually. Suppose this is an interface. This is the interface, and this medium is denser medium I am taking. Therefore, here I am writing denser medium, and its refractive index is, let us suppose, mu 1, and this side, that is our one, is, let us suppose, a rarer medium, rarer, and its refractive index is mu 2. Now let's assume that object is somewhere here. Then light ray will come here like this, and after refraction it will bend away from the normal. So this light ray will go like this. Okay. If I am drawing here one normal like this, and one ray which is going straight like this, I will denote it with a dotted line. And from this side we are watching this ray. So here is I. You are looking from this side. So what will happen when you are looking from this side? You will feel that object is somewhere here. There is object somewhere here. This I am indicating with dotted line. So actual ray will go like this, and it will reach our eye, and our eye will feel that this ray is coming here, because our eye perceives it as a along straight line. So here is your object O, and here is the image, right? Now let us suppose this angle is theta 2. What is this angle? Theta 2. And this side, this angle is theta 1. Which one? This angle. This angle is how much? Theta 1. As this is theta 1, this is also theta 1. And let us suppose this angle is how much? Theta naught. And let's give one point name here as a. This point is point A, and this ray will go straight like this. This one ray I am taking is going straight, and then this is going like this, because when we have incident normal, then it will go straight undeviated, okay, from this object. This part we don't want, or even if you will keep also not an issue, right? And this point I am giving it as a name as a B, right? Now see, consider an object O. See the diagram. Consider an object O in the medium after refraction. After refraction, the ray at the interface bend. Obviously you can see here this is interface. Shall I write here in small word, that is interface? Interface. Where is interface? This one. Okay. Consider an object O in the medium after refraction. The ray at the interface bend. The ray at interface bend. Can you see? At interface bend. Where is its interface? Yes, where is its interface? At this point A. Right? So if you have seen in the diagram, this ray is going away from the normal. Now this, when this bent ray reaches our eye, what happens? See here, second point I am writing here. When the bent ray falls, when the bent ray falls in our eye, our eye perceives it along a straight line. Along a straight line. And it appears at eye. And it appears at eye. Now, see, for nearly normal incidence, for nearly normal incidence tan theta 1 is nearly equal to sine of theta 1, and that is equal to, see here, sine theta 1 means this triangle, which triangle, OIA, right? Which triangle that is? OIA. OIA or OBA, you will take OBA, we will take, right? Because it is a right angle triangle. So I am writing here after this, that is AB by BO. AB by opposite by hypotenuse. So you should get this AO, right? So this should be AO. You can see this triangle OBA. Okay, which triangle? OBA. Okay, right. So that is what. And if suppose I will take tan theta, because I have equated here, I am taking this sin theta means what I am getting? AB by this AO. But sin theta is equal to tan theta now. So therefore, what I am doing here, instead of taking this AO, shall I take this one? OB, OB. Why? Because this AO is nearly equal to OB, because here already I have equated this tan theta 1 is nearly equal to sin theta 1. So you have to take sin tan theta ratio. That's why I got AB by OB. Because condition is what? Nearly normal incidence. So we have to treat this rays as a nearly normal. That's why this OB and AO are, we are taking nearly similar or same, we can say. Next one, tan of theta 2 is equal to sine of theta 2, and that is equal to, so shall I make it here 2 instead of this dot? Okay, I will make like this theta 2. Instead of this theta naught, I am making here theta 2. So therefore, tan of theta 2 is nearly equal to sine of theta 2, and that is equal to, again you are getting AB by IB, AB by AB by IB. So which triangle this is? Triangle IBA. So this is also theta 2, that's why this is also I am making theta 2. Okay. Okay, understood? Just we have taken these triangles. Let's move ahead now. Next. So shall I give here equation number 1 and this as equation number 2. So from equation 1 and 2, from equation 1 and 2. What is our equation 1? Tan theta 1 is equal to AB by OB. Tan theta 2 is equal to AB by IB. Right? So I am taking here like this. Sine of theta 1 divided by sine of theta 2 is equal to IB by OB. IB by OB. How we got? AB will get cancelled when you are dividing. Shall I show you that also? I think not necessary. Right? Is it necessary? Okay, I will show you. Wait. Now see here, sine theta is what we are getting, AB by OB. So substitute there, AB by OB divided by, what we got next, AB by IB. So this is what, AB by IB. So this AB and this AB will get cancelled. So what is left here? IB by OB. IB by OB. Got it? How you got this? Now, at the point A, what I am doing, see, at the point A, can I write like this? See here, mu1 sine theta 1 is equal to mu2 sine theta 2. Mu1 sine theta 1 is equal to mu2 sine theta 2. Right? See here, this is mu1 sine theta 1 is equal to mu2 sine theta 2. So therefore sine theta 1 divided by sine theta 2 is equal to mu2 by mu1. Mu2 by mu1. Keep it in a box. And even this side you got this one I am writing here. So you got here also sine theta 1 divided by sine theta 2 is equal to IB by OB. So you can keep this also in a box. Let us assume that this is your equation number 3 and this is your equation number 4. What is this equation number 4? Okay. So now this AB, this IB is what and this OB is what? In the diagram you see I to B means what? Apparent depth we can see. IB is apparent depth and BO is real depth. Yes or not? So here I am writing in the box, you can see OB OB is real depth, means where object is there, right? And IB is apparent depth. IB is what? Apparent depth. And if suppose I want BI or OI, particularly OI, OI is what? Shift. Yes or not? OI is what? Shift. So this is very important. You just keep it in mind. OB is real depth, IB is apparent depth, and this OI is shift. So here, from this equation number 4, from equation 4, can I write like this? Sine of theta 1 divided by sine of theta 2 is equal to, or even 3 also. So from equation 4 and 3 I am writing, so that I want to write combined formula. Sin theta 1 is equal to sin theta 1 by sin theta 2 is equal to mu 2 by mu 1 is equal to IB by OB, and that is equal to apparent depth by real depth. Apparent depth by real depth. Apparent depth by real depth. So therefore, mu 2 by mu 1 is equal to apparent depth divided by real depth. Right? Understood? This is very easy, just you have to do the mathematics something. Now, how to find shift? So let's find out shift. Now let's find out the shift. Shift is what already I have shown in the diagram. You see shift is OI. So OI is equal to OB minus BI. Can I write like this? See, what I'm going to write, shift is equal to from diagram OI is equal to what? OB minus BI. OI is equal to OB minus O BI, not OI. So OB minus BI. So therefore this shift is equal to real depth minus apparent depth. So whenever they are asking you find out shift, what you will do? You will just subtract real depth from, or apparent depth from real depth. Now this is equal to this real depth as it is I am keeping minus this apparent depth. Let's go back. So if I want apparent depth, what you will get from this real depth into mu2 by mu1. Yes or not? See from this. Just transfer this real depth that side. So shall I give this equation number 5? So I am writing here real depth into this mu2 minus mu2 by mu1 into real depth. How you got? This side I have explained. See here from equation 5, mu2 by mu1 is equal to apparent depth by real depth, है ना? Apparent depth divided by real depth. So therefore, apparent depth is equal to mu2 by mu1 into real depth. Like this you will get. Is that clear? So this is equal to real depth into bracket 1 minus mu2 by mu1. 1 minus mu2 by mu1. So this is what your shift formula you got in terms of apparent or real depth. Only real depth is given, then you can use this refractive indices and you will get the answer of your shift. If suppose you have given real depth as well as apparent depth, just subtract them, you will get the shift from this. Okay, understood? Okay, understood? Just a very small topic, just to try to understand. You can do it yourself once writing part is finished. So here we have taken object at this point, and when this ray after reflection meets our eye, I perceives it as a straight line, and that's why its image is appearing here. And just geometry part we did, and we have find out this apparent shift and or shift, apparent depth and real depth. Even if suppose you want anything, you can find out from this formula where it is, this common formula. Whatever they are giving, you just use this formula which I have kept in box. So either they are giving real depth or whatever, you can just use this, you will get the answer. Okay, so let's stop here and please revise this properly. And I have given you assignment on reflection. Please solve that. Don't neglect it. So let's stop here for today. Bye.